students, welcome to Legacy IAS Academy. In this particular video, we are going to discuss about a very important geophysical phenomena, that is earthquake. Earthquakes are also referred by other term seismic event or seismicity. So let us try to understand and carry out an in-depth analysis of how, why and what of cyclone. Now first of all, if we try to define it in simple terms, what is the earthquake? Now as far as the earthquake is concerned, earthquake is what happens when geographers define it as two blocks of rock that they are sliding past each other. When they begin to move in relation to each other, you have sudden slipping, and that sudden slipping is what we call as earthquake. Now basically there are certain terms that are used in reference to earthquake. Let us try to understand them one by one. Now as we have discussed that in the event of earthquake, you have a slipping between two rocks or relative motion between two rocks. So the place where rocks slip past each other, for example, these two rocks are arranged like this and suppose they are moving in opposite direction. So around this plane we can say is that rocks are slipping. So that plane along which the rocks slip are called as fault or also called as fault plane. Now also we have another term that we use with reference to earthquake is hypocenter. Hypocenter is also referred by other term called as focus, which is a more known term. Focus refer to that place deep below the earth's surface from where the seismic waves originate. For example, every motion that takes place between the rock system of earth releases energy, and this energy propagates itself, travels in the form of wave. These waves are what we call as seismic wave, and in more simple term they are also referred as earthquake waves. So the place exactly below the surface from where the seismic waves originate, which can be considered as origin point of earthquake also, is referred as focus or hypocenter. Now as the waves radiate out in all the directions, obviously if a simple question is asked that which place will be the wave will reach first, the obvious answer will be the place on the surface which is at the shortest possible distance from the focus. Now the shortest possible distance from focus is nothing but the place and the point lying directly above the focus. So the place where wave reach first at the surface, lying directly above the focus, is the place which is referred by the name of epicenter, by the term of epicenter of earthquake. And obviously because the intensity of wave is highest here, maximum here, the magnitude of energy that they are carrying is highest here, the damage resulting due to earthquake also is highest near the epicenter, and as you move away from epicenter, the damage, destruction and the overall effect of earthquake keeps on diminishing, keeps on declining. So fault plane, hypocenter, epicenter. In other way, we can also define earthquake is a large scale tremors. Tremors is a vibration, a large scale vibration that generates in the earth or above the earth's surface whenever you have displacement or disturbance in the earth's crustal rock, whenever you have some kind of motion between the rocks as such. And this disturbance is largely of what you can call as a transient nature. By transient nature means disturbance is not permanent, otherwise earthquake will keep happening continuously. Whenever we experience earthquake, it occurs for a few seconds, and that is because disturbance, once disturbance has taken place, everything again returns to the normalcy, returns to the state of calm, and the waves basically disappear. Now as we have discussed that when the seismic waves reaches the earth's surface, this is what we feel as the main shock. That is when you have large scale vibration, you have large scale shaking of the ground. You would see the surrounding at what you can call as structures around you. For example, buildings are there, trees are there, electric cables and poles are there. They began to shake violently. So this is referring to the main shock event. Now before main shock reaches the earth, you also have a shock that is called as foreshock. Foreshock in simple terms can be described as that earthquake that precedes larger earthquake but in the same location. That means you might experience a very small scale, low intensity shaking, and after some time you will have the another event where you have large scale shaking. So the first event is what we can refer as foreshock. Now once the main waves or what we can call as the main shock event has subsided, after some time you can have another low intensity shaking that is referred as aftershock. So clear from the name itself, that shocking event which are related to small scale earthquake, a small magnitude earthquake that occur in the same area during days to years after the larger event or main shock is called as aftershock. Aftershock happens because as the rocks begin to readjust themselves, during the process of readjustment also some amount of energy is released along the fault, and this then reaches near the epicenter, causing the aftershock as such. So basically we can say, if you look at the chronological order in which we can experience earthquake, it is the foreshock before earthquake, main shock related to the main disturbance in the rocks, and aftershock related to the minor adjustment in the rock system below the earth's surface. Now the question that might come into your mind is that why we experience earthquake and why we have disturbances on or below the earth's surface. The reason is because if you look at the structure of earth, it is not a uniform structure, it is not a single layer, but earth is divided into 3 layers as we go from surface to the center. The uppermost layer is what we call as crust, below crust you have the mantle, and the innermost layer is what we call as core. Now it is the crust region, the upper part of crust, which makes up your continent, and also it makes up your ocean basin. And the crust itself is not a single layer. Crust, or also which is referred by the other term of lithospheric slab, is made up of multiple smaller portion and fragments we can say. These individual fragments of the crust are referred simply as plates. And now if you turn your gaze toward this image diagram map, you would see that the entire earth is divided into multiple plates here. Some plates are largely continental because they cover continental land masses. Some plates are largely oceanic because they are below the oceanic surface. For example, Pacific plate, oceanic plate, Australian plate is an oceanic plate. Apart from that, other major plates such as African, Eurasian, North American, South American, Antarctic, these are example of continental plate. So overall we have 6 major plates and then about 9 minor plates around the earth as such. Since we are largely concerned about India, we can take a look at the Indian plate here. So as you can see, Indian plate is lying, or basically is composed of a part of Indian Ocean as well as the entire South Asia as such. So Indian plate is an example of minor plate, smaller in area, and it is also moving both in the east-west direction along this particular spread, and it is converging toward Eurasian continental plate, and that is why you have formation of Himalayas. CC convergence is the process here. Now what happens is that the plates, as we have described in the last slide, they are not in a state of steadiness, rather they keep moving related to each other. Due to the plate motion, as we have discussed, plate can be classified either as an oceanic plate or they can be classified as a continental plate. So when two plates move toward each other, it can be ocean plate, continental plate, or two ocean plate. So based on that, you have different type of motion. So if two plates are moving toward each other, for example, it is referred as convergence. Convergence can be between two oceanic plate, convergence can be between two continental plate, convergence can be between one oceanic and one continental plate. Then apart from this, if two plates are moving away from each other, apart from each other, it is referred as the motion of divergence, which again is generally of two types that we encounter right now on the earth. You have OO divergence when two oceanic plates are moving away from each other, or you have CC divergence when oceanic plates, two continental plates are moving away from each other. And the last type of plate interaction is what you refer as transform plate interaction. Transform plate interaction is where the plates are neither moving toward nor away from each other, rather they are sliding along a common boundary like this. So this kind of motion where the plates are neither moving toward nor away from each other, sliding past each other, is what we call as transform plate interaction. So total 6 major types of plate interaction, as we can see, is going on the earth's surface, and whenever these interaction goes on, you have the displacement of rock, you have the compression of rock, you have the pulling, that is tensional forces pulling away the rock, and that creates release of energy, which then propagates in the form of seismic wave, giving us a feeling of earthquake as such. So for example, we can take a look at this particular image. You can see that you have two major plates or two major rock system. One rock is moving in the northern direction, other rock is moving in the southern direction, and this is the zone where rocks are being basically pulled apart, the rocks are undergoing deformation, where rocks are feeling pressure, where rocks are feeling both tensional force, compressional forces. So these various type of forces that act upon the rock causes them to adjust, causes them to break, causes them to rupture, releases the energy which we experience in the form of earthquake as such. Now, also we have to understand that the energy released during the event of earthquake is in the form of waves. These are called as seismic wave. Seismic wave can further be classified into two categories. One is the body wave. Now, body waves here refer to such waves that flow through or travel through entire body of the earth, that means the interior of the earth. Similarly, other kind of wave is what we call as surface wave. These waves only develop above the earth's surface, not below it. The body waves are largely of two types, P wave, S wave. The surface wave is also of two main type, that is called as love wave and Rayleigh wave. Now, if you take a look here, we can see that body waves that such as P wave travel in the form of compression and expansion. S wave travel in the form of crest and trough, that means they create a kind of wave like deformation to the structure from which they flow through. You have the love wave, that is a type of surface wave. They also causes displacement but in horizontally opposite direction. For example, you can see this part of rock is displaced behind, this part of rock is displaced forward. And then you have the R wave, which is nothing but a combination of P wave and S wave. That means when R wave passes through any particular structure, they causes basically a stretching, that is compression, as well as the expansion of the rock, and also they cause the rock system, the structure to move in a wave like fashion, wave like order as such. So that is how these four waves propagate. The P wave is what we have to understand is the fastest one, and that is why they are recorded first by the seismograph instrument that is used to measure the seismic wave as such. Now, let us try to also understand about major differences between the P wave and S wave, because these are the most important wave as such. P wave or primary wave are longitudinal wave like sound wave. They travel in the form of compression and expansion, as we have discussed. And the most interesting thing is that P wave can travel through all the three medium, whether it is solid, liquid or gaseous. Velocity is directly dependent on the medium. They are least destructive and their velocity is almost 40 times higher than that of S wave. On the other hand, if you look at the S wave or secondary wave, they travel in the form of light wave. We have discussed already. They travel in the form of what you can call as in the form of transverse wave, creating crest, that is the risen part of the wave, and the depressed part of the wave is called as trough as such. They cannot travel via liquid or gaseous medium. S wave only travel through the solid medium. They are highly destructive because when they pass through any structure, there is a high probability of the extensive damage and shaking of that structure, and because they are slower than P wave, they are recorded after the P wave as such. Now, because S wave can travel only through the solid medium, the outer core of the earth, as we know, is made up of liquid. So, when from the point of focus, waves radiate outward in all the direction, we can see that they are not able to travel through, they are not able to pass through this particular part of the earth because this is in liquid phase. So, they deviate, and that is why only between 0 degree, that is a line directly above the focus, and up to 103 degree, if you measure from there, is where S wave is recorded. Beyond that, S wave is not observed, and this region where S wave is not recorded, is not observed, is called as the shadow zone of S wave. P wave can travel through all the medium of the earth, but the problem is that when they pass through the center part of earth, there is a sudden change in density, a drastic change in density, due to which wave undergo the process of refraction. Refraction you might have heard about in the phenomena of light. When the waves enter from lighter medium to denser medium or vice versa, they are not able to travel in a same line, same path, they deviate away. So, due to this deviation, again between 103 degree to 145 degree or 50 degree, we can say roughly, P wave is not recorded, and this is what we call as the shadow zone of P wave. So, what point we have to keep in mind here, that both waves, whether they are P wave or S wave, they create shadow zone. However, the shadow zone of S wave is much more larger, much more bigger on the earth as compared to P wave compared to the shadow zone of P wave as such. So, that is about the pattern of the S wave and P wave. Now, we have discussed that earthquake releases seismic wave. These waves are recorded by seismograph at the surface, and then the intensity, magnitude of earthquake can be measured. So, two main scales are used to measure and represent earthquake. One that measures the magnitude of earthquake, that largely determines the amplitude of the wave, is what we call as Richter scale. And second, this scale is called as modified Mercalli scale, that measures the intensity of earthquake as such. So, these are currently two scale that is used across the world today. So, first of all, if you look at the earthquake magnitude scale, that is Richter scale, it measures the value of earthquake on a scale between 1 to 10 as such. However, interestingly, we have not recorded any earthquake of magnitude 10 in the human history. The highest magnitude earthquake that we have encountered is in the range of 9.6 as such. So, basically, on the basis of how large is earthquake, value can be assigned between 1 to 10, and obviously as you go higher up the scale, the devastation, the energy released and the earthquake by the earthquake will keep on increasing as such. For example, earthquake of magnitude 9 releases 30 times more energy than earthquake of 8, which releases 30 times more energy than earthquake of 7, and vice versa. That means every unit change on the Richter scale represent almost 30 times increase in the energy released by the earthquake. In other way, we can say an earthquake of magnitude 9 will be 27,000 times more stronger, more intense than earthquake of magnitude 6, and that is why earthquake of magnitude 6 you can consider it as moderate, while 9 is catastrophic. It will topple up almost 60, 70, 80% of the buildings in this particular area as such. And we can understand from the fact that a magnitude 9 earthquake releases the energy that is equivalent to almost 20 trillion kilogram of TNT, that is trinitrotoluene, toluene, the explosive that largely is used here. And as compared to earthquake of 1, it has only 20 kg. So, 20 kg of energy, TNT energy, and here you have 20 trillion kg TNT energy. That is the big difference between the values of Richter scale. Now, if you look at the major earthquakes that we have witnessed across the world, we can see you have magnitude 9.5 earthquake, one of the most devastating earthquake in the recorded history of the earth in the humanity, occurred in the year 1960 in the Valdivia region of Chile. For example, next in 1964 you have magnitude 9.2 earthquake, that is in the Alaska, USA, 9.2 in the Sumatra, Indonesia, 2004. Now, if you remember, this earthquake is the triggering event for the 26th December 2004 tsunami that has struck almost all the countries of Southeast Asia and also has caused extensive damage in the Andaman Nicobar Island and the Tamil Nadu coast of India as such. So, this was the earthquake resulting into tsunami. 9.1 earthquake, Tohoku, Japan, 2011, that also has resulted into a tsunami that has led to Fukushima nuclear disaster in the Tohoku region of Japan, and 9.0 magnitude earthquake in the Kamchatka region of Russia in the year 1952. So, these are some of the mega thrust earthquake, some of the super earthquake that we have encountered on the earth in the human history as such. Now, you will think that it is only the magnitude of earthquake that can determine that what kind of damage, destruction, and to what extent people's life and economy will be impacted. It is not so. Apart from magnitude, there are several other factors that determine the deadliness of earthquake. This can be architecture, what kind of buildings have been created, whether the buildings can withstand the forces and the energy released during the earthquake. For example, Japan is a country that experiences more than 600 earthquake events in a year, but they have constructed their building, they have taken into consideration the architecture plan of the building in a manner that these buildings can withstand moderate to damaging earthquake as such. But in case of many countries including India, a lot of buildings are not made following the earthquake building code or seismic building code as such. Density of population also is a major factor. If earthquake is taking place or has occurred in the high population density areas, damage, destruction and the loss of life will be humongous in nature. Apart from that, local geological condition, how stable is the soil, how stable is the rock will also determine the damage, and distance from the epicenter. As you have discussed, near epicenter will have maximum damage, away from this, apart from this you will have less damage, and how far below the surface of earth earthquake is taking place. If it is taking place far below the earth's surface, by the time energy is reaching the surface it would have lost most of its value, thus damage could be limited in nature. Now, coming to the classification of earthquake can be made on the basis of the regions and the causes of earthquake, and this can be broadly defined as natural earthquake or the anthropogenic earthquake. Natural earthquake, clear from the term itself, refer to such earthquake that takes place because of the natural factors, geophysical phenomena originating inside the earth. This can be tectonic, as we have discussed, it relates to the plate motion. This can be volcanic. That means whenever you have volcanic eruption, whenever magma rises from below above the earth's surface, they also causes disturbances in the rocks. Then you have faulting and fracturing because this crust of the rock keep on undergoing compressional and tensional forces, experiencing compressional and tensional forces. So, faulting and fracturing can also trigger earthquake like event. So, these are the three: tectonic, tectonic, volcanic, faulting earthquake, and then you have human based earthquake, human genesis earthquake. Anthropo means human, genesis genic, and these are RIS. RIS is what we call as reservoir induced seismicity. So, reservoir induced seismicity is an earthquake that largely takes place due to the construction of dam along the course of a river. As a dam is constructed along the course of river, the water volume keeps on increasing and the hydrostatic pressure on the ground will increase. Many times the soil or the surface, the rock is not stable enough to accommodate this high hydrostatic pressure. They cave in under the influence of water, and thus it also trigger a kind of disturbance which results in the earthquake as such. The best example of this we can see in the Koyna earthquake that occurred in the Maharashtra when a dam was constructed over Koyna river in the year 1967. Its magnitude was moderate of 6.5 on the Richter scale. Mining can also trigger earthquake because we are excavating, we are disturbing the rock. Oil well drilling, again we are fracturing the rock system, and the testing of weapons, especially nuclear weapons or large scale bombs, can trigger earthquake as well. Other method of classification of earthquake is on the basis of depth of focus. In the beginning of video, I told you that the place where seismic waves reaches first is called as epicenter. Lying directly below the epicenter is the focus, which is the origin or source of earthquake, source of seismic waves. So, how far this distance is what determines earthquake as well. So, if this depth is less than 50 km, we can call this earthquake as a shallow focus earthquake. If the depth is between 50 to 200 kilometers, we call it as a medium focus earthquake. And if depth, many times medium focus earthquake is also called as intermediate focus earthquake. So, both terms are used here. And then you have deep focus earthquake when the focus is greater than 200 kilometers. Now, I would want you to comment in the comment box that out of the shallow, medium and deep focus, which earthquake will be more disastrous, more deadly in nature. The third basis of classification is on the basis of human life lost as a result of earthquake. So, if human casualty is limited up to 10,000, we call it as a low intensity earthquake, and most of earthquake, we can say almost 80 to 90% of earthquake that encounter on earth belong to this particular category. If human life lost is between 10,000 to 50,000, it is referred as moderate intensity earthquake. Example we can give from India itself is Bhuj earthquake of year 2001. It was an example of moderate intensity. Third is high intensity earthquake when the life lost is in the range of 50,000 to 100,000. In the year 2023, 2 years back, Turkey has witnessed one of the most devastating earthquake in its recent history. Here more than 60,000 people lost their life. That is the high intensity earthquake. And very high intensity earthquake is where more than 1 lakh people have lost their life. Again, we can take example from Kolkata. Kolkata in year 1730s, you have casualty figure up to 3 lakh. So, this is an example of very high intensity earthquake. And here also, if you look at the earthquake which has led to maximum human casualty in the entire human history, we can talk about the Shaanxi earthquake of China, where reportedly 800,000 people lost their life. This earthquake occurred somewhere in the year 1556 as such. So, this is how we can classify the earthquake on the basis of intensity, low, moderate, high and very high as such. Now, we also have to take a look at the region of earth which is most prone to earthquake, and this we can understand again from the fact that in the beginning I told you earthquake is a result of plate interaction, plate movement, plate tectonics. So, if you look at these particular areas, for example, along the entire circumference of Pacific Ocean, you can see this area is called as circum-Pacific belt. It also is referred by other term, that is ring of fire. The reason is because this entire area is where oceanic plate and continental plates are interacting. There is a kind of subduction that is going on, convergence that is going on. So, you have a lot of volcanoes all across this rim, and because of volcanic eruption you also have more than 60% of global earthquake taking place in this particular zone as such. The second deadliest zone for earthquake is this one called as mid mid-continental belt. Now, as you can see, mid-continental belt extends all the way from Asia, that is South Asia, Southeast Asia, passing through the Central Asia, West Asia, and then going all the way up to the Western Europe as such. So, this zone, and then it further extends to China as well, is called as mid-continental belt because it is lying in the middle of the continental land masses. So, basically along this belt, you have continent-continent convergence, where this entire plate can be called as Eurasian plate. And from the south, you have three major plates, that is the Indian plate, you have Arabian plate, and you have African plate. They are pushing against the Eurasian plate as such. So, because of this, rocks is getting continuously compressed. They get basically compression releases energy whenever rocks break, and this energy that releases is then manifest itself in the form of seismic events or earthquake like event as such. So, that is how we can understand this area is also a major earthquake prone zone, and reportedly about 21% of global earthquake is taking place in this particular area. Third belt we have is in the East African area, where you have this part of Africa and this part of Africa. Rocks are being pulled apart, plate is being pulled apart, so they are diverging, and due to divergence again you have earthquake, volcanic eruption. Then you have the belt in the middle of Atlantic Ocean. If you look at this particular area here, kind of S shape, we can say roughly S shape belt, passing through the Iceland country, small country that you have here, all the way up to the Antarctica or the southern ocean as such. And along this belt, basically the ocean plates are diverging, drifting, they are moving away from each other. Interestingly, it means that every year Europe and North America are drifting away from each other, the distance between them increases, and because of this divergence at a lot of places you have volcanic eruption, such as Iceland is known for volcanic eruption, Azores Island you have here is known for volcanic eruption, and this then also triggers a moderate, low to moderate intensity earthquake as well. So, this belt is what we call as mid-Atlantic belt. I can write the name here to make it easier for you. This is the mid-Atlantic belt. So, what we have discussed: Circum-Pacific belt around the circumference of Pacific Ocean, mid-continental belt, mid-Atlantic belt, and the East African belt as such. So, these are the major belts where you encounter majority of the global earthquake. Now, let us try to look at India. The reason why India, especially the northern part of India nearby the Himalayas or sub-Himalayan region, which are experiencing or which have experienced highest number of earthquake in India, is because of again the plate motion. As I told you, Indian plate has drifted continuously, has moved continuously from south to north, and somewhere about 10 to 20 billion years ago, it collided with the Eurasian plate as such. So, this resulted into a plate interaction that we call as continent-continent convergence. This resulted into the upthrusting, upfolding of the rocks and sediment along the boundary areas. As you can see from here, this has resulted into the formation of Himalayan ranges from north to south, and still Indian plate is pushing against the Eurasian plate. Even today, it is pushing against the Eurasian plate at a rate of somewhere we can say 4.5 centimeter per year, and this stress is continuously being applied on the rock, and whenever stress becomes sufficiently high, rocks get displaced, they break apart, and this energy is then released, and then in the Himalayan, sub-Himalayan zone, you experience this release of energy and reception of this energy in the form of earthquake as such. Now, on the basis of earthquake in India, entire India is divided into 4 zones, 2, 3, 4, 5, based on the probability of the earthquake and intensity of earthquake. So, as again you can see, major part of the entire northeastern India, where you have Himalayas extended, and then parts of Jammu Kashmir, Uttarakhand, Himachal Pradesh, and part of Bihar near the Nepal border is in the zone 5. What does zone 5 mean? Zone 5 means that these are very high risk zone. These are area liable to shaking intensity of 9 and more. That means damage, destruction can be catastrophic in nature if high magnitude earthquake occur here. Around this dark red region, you can see orange area, that is on the boundary side. Interestingly, you will see one very high risk zone you have also in the Bhuj. This was recategorized after 2001 earthquake. So, around this area also you have high risk zone where you can have intensity of 8. You have zone 3, that is the majority of the earthquake zone, that is represented in the yellow color of zone 3, and then you have zone 2, that is low risk zone, based on the modified Mercalli scale of intensity 6 and less as such. So on that basis we can classify entire earth area of India into different earthquake zone. That is all about this video. I hope you like the video. If you understood the concepts of earthquake, if you like the video, please hit the like button, share it with your friends, subscribe to the channel for more such content. Thank you very much.